Hey everybody, how's it going? My name's Matt DiNapoli. I'm the head of strategy, for the DevNet program. Co-presenting with me today is Shannon McFarland, the VP of our DevNet program as well. We're going to set some context before we get started here, talking about what we mean when we say the stack in using using GenAI in our operational opportunities within our IT organization. I also want to set the table about putting programmability and automation into practice within our organization as well. And then we'll jump into how we can start to leverage GenAI tooling for infrastructure as code, or IAC. Shannon will then jump on stage. He's going to move up the stack and talk about AI infrastructure and how we can leverage agents within our infrastructure and help us deploy applications and monitor applications. We're also going to look at opportunities within orchestration and observability and securing the AI infrastructure. So let's not waste any more time and get started. So as far as setting that context, when we talk about the stack, I've been thinking about it for the last few years around something similar to the OSI model. A lot of us here are familiar with that. And it might be a little bit of a shoehorned analogy, but it helps me understand and think about the IT infrastructure stack a little bit better. So the idea is that the layers at the bottom have to exist and work very well for the layers at the top to accept those services. So we can't have an application layer at the top in our OSI model without the physical infrastructure, the data links, and the network layers working well. Same thing goes for our infrastructure stack. So our network, storage, and compute has to be there, whether it's on premises or in our cloud services. For the opportunities for virtualization, developer tooling, container and orchestration, and ultimately delivering our applications to our end users. And then pervasive in all of that is a concern of security in all of those layers. So that's how I think about it. Oops, I didn't realize that's what we were supposed to be looking at while I was talking about that. Sorry about that, I was looking at the wrong slide. So again, going back, that's how I think about it. In this, we're going to be focusing on areas of IT operations, how we're going to not just automate and provide programmability instances into our IT operations, but how we can take advantage of DevOps practices as well to provide infrastructure as code opportunities for our IT organizations. So how can we put that programmability into practice? One of the main things that we run into in DevNet in talking about automation and programmability is a little bit of a hesitancy in understanding the value proposition for automation and programmability. But what we have been telling people for 10 years, and we're still telling the same story today, is that it helps us with scalable deployments and maintenance. So we're actually putting these repeatable processes into code, things where we historically might have logged into the CLI through either the management console or Telnet or SSH and gone through and typed in configuration commands and done this over and over and over again in our devices. We can now put into YAML files that we can run over and over again without having to do those things for tens of devices, hundreds of devices, thousands of devices. So that gives us that opportunity to scale our deployments and save a ton of time while doing it. It also gives us an opportunity to have a more visible source of truth. It provides us accountability into our deployments, and it also gives us visibility into version control. And what that does, as far as change tracking is concerned, is if we run into situations where potentially we have an issue with the deployment or we're running into some problems, we can actually go back and maybe even possibly roll back some of the deployments that we've done. And through that, we've been taking advantage of processes that software developers have been using for a couple of decades, actually. Automation pipelines that help us integrate our testing platforms, whether it be use case testing or integration testing. And it helps us to control those deployments in a more visible way. And honestly, I have to say it's just more fun. One of the best feedback that we get year over year, especially in the DevNet zone, is that those people who have gone through and worked for organizations that have adopted a programmability and automation practice, they're really excited about the solutions that they're coming up with. They're really excited to share their code with us. They're really excited to share their solutions. And ultimately, because of these optimizations, yes, of course, there's work that goes on the front side of it, but all the times it's then saved on the back end allows these engineers then to tackle more interesting problems and honestly provide more innovative solutions to their organization. It doesn't come without its challenges, though, of course. What we've found is, even though there are organizations where the engineers themselves try to start grassroots programs, it's hard for them to get that traction unless they have that top-down support. And it's really a cultural investment from leadership to make that happen. It has to be organizationally bought into. There's an investment that has to occur in that enablement. You have to upskill and train your employees, provide tool sets that buy into the automation and programmability processes, and ultimately change the way your IT operations are occurring. Now, we all know that, especially for IT organizations, we have to have things running all the time, and we have to make sure that we're continually productive. And a lot of us work for companies that like to continually make money. And so sometimes that day-to-day gets in the way, and that's a significant challenge, because if something's working relatively well, it might not be hyper-optimized, but if it's working really well, we don't necessarily want to take the chance to change something. The old adage, if it ain't broke, don't fix it, comes into play there. And that can get in the way of change, and change can often be scary. So how can GenAI help with some of these challenges? And we'll actually look at some very specific opportunities through some of the demos I have and some of the ones Shannon has. But as far as those challenges that we're looking at, obviously the top-down support, that has to come from management, has to come from people. GenAI can't necessarily help with that, at least not today that I know of. But where we can see some opportunities are in the training, in the tools, and in the operations. So as far as training is concerned, we still have to go through the learning process. We still have to upskill our engineers. But the training itself can be short-circuited as we build things out. So we can actually add in the opportunity to build while learning using GenAI tooling. And there's a little bit of an example I'll show in a minute there on that. As far as tools are concerned, similarly, I'm going to show you an example about using an Ansible creating an Ansible playbook. Ansible is one of the main tools that we're going to be using for infrastructure as code. And you might, as an engineer, not know a ton about Ansible or how it's used or building playbooks, but we can start to leverage GenAI to help quickly build out things that might have taken us a few days or a few hours, and boil it down to maybe even a few minutes, depending on how quickly you're on the uptake. And then ultimately, that training and tools, those efficiencies can be bled into operations as well. If we are realizing acceleration in the training and tools and operations, then that day-to-day potentially gets a little bit easier, because it's leaving a little more room for us to spend time on that enablement and ultimately, hopefully, make that change a little less scary. So usually when we talk about net DevOps or DevOps processes, we look at the CI/CD functional view, and this is where we want to look at AI insertion in that. And so where we have our little brain icon is where we see opportunities for GenAI to help us out. So I've seen some really cool tools in the last few months around planning, generating product requirements documents for deployments of not just software applications, but services as well, hardware services as well. We've all seen the stories, if you haven't started using them yet, around code assistants. Code assistants are becoming hyper-pervasive in the developer space, and they can also be used within our infrastructure as code management areas. I've also seen some really cool tools around unit testing, integration testing as part of the flow, and then actually Shannon and I are both going to show a little demo here as we get into kind of day 2 operation and observability activities. So specifically though, for GenAI and infrastructure as code, what can we do? So I'd mentioned Ansible earlier. We could be using our GenAI tools to shallow that ramp that it might take for us to get involved in Ansible, start using Ansible in our IT organization, and even Terraform as well. Within the testing space, we can start to leverage our GenAI tools to help us build test cases with PyATS, tie that into our virtual environments in Cisco modeling labs, and even help us generate synthetic traffic to actually test the load of our environments as well. From an operations side, we can use the combination of predictive AI and GenAI to help us with issues. G2 was just talking about that. To provide mitigation and optimization solutions on the fly, and we're actually going to see a really cool example of that in a minute here, and then hopefully provide not just end-to-end security, but visibility into that security as well. So some really exciting things that can really help us accelerate our opportunities within infrastructure as code. So I mentioned coding assistants before, and there's a ton of them, and for a lot of you network engineers out here, infrastructure engineers, you might not be as concerned with coding assistants, but they actually can help us with a lot of different areas that we are interested in. GitHub Copilot, Cursor, we've been hearing about them for about the last year and a half or so. But there's also ones that are very specific to our industry. So this particular demo is going to show us how we can use GenAI, leveraging Ansible Lightspeed, to build an Ansible playbook. So in this demo, we're going through a set of steps that are called out here for configuring and setting up a 9300 Cisco switch, Catalyst switch. And it's generating our playbook for us. I've only given it instructions on what I want it to do. It's set up the YAML for me, which is kind of a pain if anyone's used YAML before. It's very fastidious about its layout. And so it's putting in the values, it's setting up the sections that I want, and it's giving me a framework that might have taken me a few days to even set up, depending on the activity. There's some other little things in there that helped me out. It realized I was doing a Cisco switch, so it's providing me documentation access for the modules, the Ansible modules for that particular platform. And then, now this example is a little circular, but assume maybe you inherited a playbook that exists and you don't quite understand what's happening. It's actually clever enough to figure out what's going on with that particular playbook and go through the tasks that it's actually taking on. So some really cool opportunities, again, to short circuit or shallow that ramp in getting into building Ansible playbooks. But it's not just about the provisioning and configuration activities. We can also blend this into our day-end activities as well. And so if we look at our network troubleshooting and remediation opportunity here, we're actually going to leverage CML for this, but I'm going to pretend like my IS neighbor interface is gone down. We can see that that has gone down in this particular graph here. And there's an AI agent running behind the scenes here that has now let me know that it's identified the fact that that IS neighbor is down, and it's going in to figure out how to fix it. So this agent has been configured and set up to identify when there's a problem with the network and provide remediation solutions for it. Now, don't get me wrong, there's been a lot of work done by my colleague Jesus Yeskis to set this up. It's not all magic. But now I have someone monitoring my network at all times, and it's able to not just figure out what's wrong, so I don't have to dig into the devices and do all that extra work. It's actually suggesting the remediation solution as well, so that I don't have to necessarily get up and get on my laptop and figure that out. I can just message it back and say, hey, yes, I'd like you to do that remediation. And on top of that, it's going to track everything that occurs to make sure that the steps that it took got our IS neighbor back up. We have a successful run of that remediation. And then if we do the review, we see our IS neighbor is up and running, and now we can actually go into the device and check that it's up and going. So I only have about a minute or so left before Shannon comes up, but I wanted to cover a couple more steps that are a little more challenging in the space, and it's a use case that our Outshift team is actually working on right now. We talked about the plan and code portion a little bit, and we also talked about steps 6-ish and 7. Shannon's going to talk about 6 a little bit more than I did. But what we haven't talked about are the pull requests, the reviews, and the merge. So when we actually start to adopt DevOps practices, one of the main things that application teams and then infrastructure as code teams get into are managing pull requests. And for up until now, most of that has been done manually. It's something that they have to go into the code, review each line of code, make sure that it's tying to policies that have been laid out for them, best practices, code quality, and consistency. And now we have an opportunity to tie agents into this, provide suggestions within our GitHub repos, create the PRs themselves, make sure that they're tying to policies that are defined for our organization, and then when we actually merge that into our main branches, we can look at that compliance with the agents and analyze the impact that it's going to be on our network. And part of that's going to be cost evaluation and resource efficiency as well. So, excuse me, some really interesting opportunities here that I was blown away when I heard about the use case and how it was being attacked, because I hadn't even thought about the capability of doing it, and I could see where that would save teams tons of time. So, that being said, thank you for your time. I'm going to pass it off to Shannon, who's going to jump right into moving up the stack.
Well, thanks a lot, Matt. And as Matt introduced me, I'm Shannon McFarland. I lead the Cisco DevNet organization. So if you have to leave early for something, please go down this hallway later on to the DevNet zone. That's our area. A lot of the things that we're talking about in here very briefly today are manifest in a lot of breakouts and demos over there. So please come and take a look. I'm going to continue the motion here with moving up the stack. I mean, Matt did a great job of level setting kind of the state of the union related to developers or operators who use developer tools, and kind of is this GenAI thing here to hurt us, or is it here to help us, right? And so I think that while there's lots of commotion around, what parts of the job can GenAI do on our behalf or in replacement of us, we absolutely, as developers, understand exactly where to leverage it, and we hope to articulate some of that stuff to you today, and where it really manifests itself today with inside of the infrastructure we're all responsible for. So if you look at a common kind of AI ML environment, many of you will have this implemented in one of two ways. You will have a dedicated AI ML environment that data scientists, for example, are going to interact with through ML tooling, whatever their specific libraries are. Very often this is sitting in some sort of a containerized scheduling service such as Kubernetes. But no matter if that's a dedicated environment with dedicated GPUs and so forth for whatever your work is, it's going to be leveraged by a multitude of entities, right? Or you could simply say, I know my Kubernetes environment well enough to know that I can use things like labels and annotations to steer specific use cases towards specific hardware that exists in a shared Kubernetes environment. And so it may be that you don't have a dedicated AI ML infrastructure, you're just leveraging parts of it for this AI environment. But the thing that we need to know about around GenAI is that this stuff is just software, right? Yes, it does magical, mythical things, but it's just still software burning up CPU, GPU, network I/O, and storage. And so at the top of this, while we may be fixated on these use cases, the reality is that it's still just sitting on infrastructure. Now, the thing that is new on the block here as it relates to all the hotness around GenAI is this thing called agents, right? And as we expand the scale of these agents, where multiple agents are working in unison to accomplish a specific outcome, we call that an internet of agents. And this is a term you're going to get worn out by hearing, because we're going to be talking about it a lot. And so this is something that is very interesting, because we can utilize, as Matt kind of showed in his demo with the Ansible demo, that we can create an internet of agents to implement new infrastructure on our behalf. Not only will they implement it, they'll help us operate it, they'll help us secure it, and so forth. And so it's an interesting thing where you're using agents to deploy an infrastructure so that more agents can run on it, right? And so it's kind of an interesting time to be in this space. So let's break some of this stuff down. So real quick, an AI agent, if you've not heard of one, is an intelligence system that is very often interacted with through a natural language process. This could be you typing in a chat interface similar to what we had in the demo. It could be you speaking to something. It's very much like an assistant that you have. So this could be an Alexa or Siri type of assistant. But these agents are way, way smarter. They're a way for us to effectively and efficiently interact with extremely complex data to generate some sort of simplistic outcome. They can be as simple as a single agent, but they're more often going to be multiple agents working in unison together. And the separator between them and assistants very often is the fact that they can autonomously not only learn, but update the way they do things in the future. And this is completely different than what you would have in a standard assistant environment. But what needs to be known in this group here today is that agents are just software, and we need to know how to automate them and manage them through APIs like anything else. And so again, while these things are really, really amazing as it relates to what their outcomes are, The fact that they are just software sitting alongside your web server or your other databases or whatever it is, you can interact with them and support them and monitor them and secure them with all the same tooling that you're already leveraging. So we can go in and utilize APIs, RESTful APIs as an example, to go and interact with them or the infrastructure that they represent. We're utilizing a lot of the same IAC, so you can use Ansible, Terraform, CDK, CloudFormation. All of these tools will allow you to manifest these agents. Why? Because at the end of the day, they're probably wrapped up in a Docker container that is sitting there inside of a pod inside of your Kubernetes environment, right? And so all of the things that you know, you can apply to that. And then the last thing for the developers in the room, they're built using the same program languages we use now. So you're not, learning some brand new programming language to go and generate these agents, whether you're in support of the agents or you're building agents to help you do your job. So now that we understand that it's about software and that we understand that pretty much everything that we have infrastructure-wise is still going to apply, there are going to be unique things that we need to understand about agentic frameworks and about GenAI components that we need to be aware of. So if you kind of take a look at what we know now is that things like large language models, agents, vector databases, common AI ML infrastructure are going to find their way onto some sort of operating system, such as Linux. So they're going to be burning processes, making sys calls, there's sockets, they use TCP/IP. They're probably going to be a containerized environment running inside of a pod, inside of a Kubernetes environment. They could be running in a hyperscaler, or if you're running in an on-prem environment, they could be on a Cisco UCS. So this is all looking pretty standard to what we're used to. However, there are unique behavioral patterns, as we'll see in the demo, that some of these tools take on that you may not be aware of. So that's where the new Cisco functionality, some of the things that we talked about in the keynotes today, Cisco Hypershield, for example, leverages a technology, and this technology, we call it the Tesseract Security Agent, is an agent, not like a GenAI agent, but another agent that runs inside of your fabric that is watching everything these things do within a Linux kernel, literally everything. Are they touching or attempting to do privilege escalation? Are they writing a binary and trying to run the binary in your temp folder? All of these types of things that you would do from a normal software pattern are being observed by this agent and being able to report to you or block these things, and this is critical inside an agent environment. You may be attaching this into a high-speed, low-latency Ethernet fabric when you're doing machine learning or inference type of work, right? And so these software patterns are still attaching to a fabric somewhere. It could be that you have part of your AI running inside of a hyperscaler environment or in a colo or in an edge environment. No matter what it is, you're going to be using SD-WAN, you're going to be using OTV, you're going to be using DCIs, you're going to be using IPsec. All of these standard things to connect these software components, you're still going to have in your environment. And so when we take a look at some of these things as they manifest into a common architecture, you may have users or additional services that are communicating with your GenAI-oriented services. So it could be your help desk, whatever your chatbot looks like. It could be that you have agents that are talking to another company's agents. Whatever that interface is, you're probably doing it over an API, and you are leveraging a backend infrastructure, large language models, vector databases, and again, these things are more times than not manifesting themselves as containers that live in a pod that are represented by a service inside of a Kubernetes environment. Okay, so pretty straightforward. And that allows us to leverage all of the goodness of all of the network semantics that we're already familiar with today. For example, OpenTelemetry, one of the most popular open source projects on planet Earth in the Cloud Native Computing Foundation. So OpenTelemetry allows you to instrument automatically or manual all of your workloads to export tracing metrics and logs in a standard format. And so we can instrument all of our GenAI and vector databases and so forth applications utilizing OpenTelemetry. We also now talked about in the keynote, G2 was mentioning Isovalent, which is a company that we acquired. They are the founders of some of the most popular open source projects in the world. Cilium, eVPF, the new kid on the block, Tetragon, and then the service mapping solution, Hubble. All of these are independent open source projects that you can implement today. You can actually come to my talk, DevNet 3310 on Wednesday. I'll actually be breaking all of these down in horrific detail, and so you can kind of understand what these things are about. But you can leverage all of that to give you not only Linux kernel visibility, but network I/O visibility all the way up to layer 7 in your entire fabric. This then yields an opportunity for you to stream all of this information into something like a Splunk environment where you're not only collecting the information, you're doing correlation to make sense of it all, right? It could be, this is really great, Shannon, that I've got a 5-tuple stream in my log and I see source dest of MAC and IP addresses, but that does not tell me what's being attacked, right? And so this is where we want to leverage the technologies that we normally leverage in the back end to instrument, but also get correlation against these solutions. And then the thing that we're here to understand is no matter what you're using, whether you're doing programmability by using an API, you're using infrastructure as code, or you're building your own agents, you're going to need automation and programmability to interact with every single part of this infrastructure. Now, before I jump into this real quick demo, what's important is what I keep repeating in this session, and that is that these technologies are just software. So the things that you've been learning throughout your entire career, the things that you've been learning this week, all still apply even when you don't understand the application. You may not understand what agents are and what large language models are, or what is LangGraph versus Crew AI versus Pydantic agents. You don't understand any of that, but what they are software. So the infrastructure that we've already invested in or that we're designing can help us in this. And so, for example, this is the Isovalent Enterprise platform using the Hubble UI Enterprise interface, and we're using Cilium. Cilium's an open source project. It's also a container networking interface, a CNI, that you can plug into your Kubernetes environment, and it gives you extreme levels of granularity and control. And so if we run this demo, we can actually see that we are saying that everything that is in this workload within this namespace can go anywhere in my cluster, but when it leaves my cluster, it can only download large language models from olama.com. So if I go into my API and I go and check my LLM, it's going to say that it's Olama, everything is good, we're good, so we can go and interact with the service through a chat interface, and we can ask it some stuff, and we're going to be good to go, right? We can actually go through there and enter our prompts, drop in our docs, and have them embedded, and everything's going to be okay, right? So we can see here now in Hubble on the right-hand side that rule is allowing us to forward stuff in there. But what we don't realize is we downloaded this thing from the internet, and we don't really understand what it's doing. It's actually making an external call to report its search analytics to another company called PostHog. So that may be totally okay. You may understand that now this agent is actually trying to do something you didn't understand, but now because you're kind of defaulting to close, you can go and block that. We can also say that you cannot leverage another LLM provider besides the one we've approved. And so in this particular example, we only allow you to download LLMs that come out of Olama. If you go to try to sign up and now use OpenAI or Azure or another service, you can leverage this technology using something that's just really there to look at the network to actually prohibit that type of behavior, okay? So until you get these fancy AI tools that we're talking about this week, know that the infrastructure that you're already investing in can help you with some of this stuff, even if you don't understand the apps themselves. So that's a quick run through of some of the stuff that we're talking about over in the DevNet zone. What did we learn out of the session? There's a lot to look at, right? There's all of these new tools and new protocols and new things that are landing on our network that we may not understand. Some of that stuff, RAG, inference pipelines, LLMs, all of these things are just software. And if it's just software, we can leverage the automation of regular infrastructure as code to get us those implementations there. We know that they're not using any new API types, REST, GraphQL, these are the things that we know. And they're also fully observable utilizing the standard melt type architectures we're used to. So this is good news. This means that we can actually go out and implement these solutions today. So our action for you is come and see us over in the DevNet zone. Certainly go look at these AI-centric solutions that we've been announcing this week, and I hope you have a good time. Thanks for being with us today.